Hello, this is Jack Jackson. Welcome to this playlist that is Unit 16 of Calculus, or Unit 4 from Calculus 3, on vector calculus. We'll be doing several things here. And this first video is just going to be a quick overview of where we've been and kind of where we're going. So it's just an overview of some things here. First of all, let's think about what we've covered thus far. Our Unit 13, or Unit 1 in Calculus 3, was talking about extending pre-calculus to new types of functions. So we looked at the meaning of relations, functions in new context, looked at formulas, tables, graphs, words, and did them in context. Some of the types of functions that we looked at, of course, in Cal 1 were mainly just real valued functions of a single real variable, so both the input and the output of the function were single real numbers, so just ordered pairs of real numbers. But in this course, now that we've done multivariable calculus, we've looked at other kinds of functions, such as the input being ordered in tuples of real numbers mapped to a real number. So say x, y as the input and output is z, or x, y, and z, and output is some other variable. So functions of 2 or 3 variables, for example. But the output was a real number. We also did a real number mapped to an ordered in tuple. For example, parametric functions were like that. We're going to review a little bit of that before we get too much into vector calculus here in our second video. But we're talking there about a real number parameter, say t or whatever, and then the out is the input, and the output is some ordered pair. The ordered pair, so parametric, say curves in a plane, or ordered triple for the output, so its an output is an xyz coordinate in space, so it'd be a space curve. And then we had some things that were related to vectors. We had functions where the real number input, output was a vector. Vector input, output is a real number. We had those too. We had a vector input, vector output. Then we did some basic operations with vectors: addition, subtraction, scalar multiplication, dot product, cross product. And so we already did all those things early in the course, and so you might want to review a few of those things about vectors if you need to. Then we also talked about polar and cylindrical and spherical coordinates and quadratic relations in 2 and 3 dimensions. We kind of did that in our first unit here, or Unit 13. Unit 14, we extended the idea of limit, continuity, and differentiation to new types of functions, particularly those functions where we had, well, actually all of these kinds of functions, but especially those that were inputs were an ordered pair and output was a real number, inputs was an ordered triple and output was a real number. But then we also could talk about limits and continuity in vector functions as well. And we talked about how to talk about limits and continuity for them, but then also about differentiation in the context of these functions mapping ordered in tuples to a real number. So then we talked about partial derivatives and directional derivatives and the gradient vector, and the gradient vector function, and the gradient vector is a single constant vector too. Optimization, extrema, and saddle points were some of the applications of those, and then we also did some constrained optimization problems as well, with one of the tools being Lagrange multipliers. So that was kind of our Unit 14. And then Unit 15 that we just kind of finished up, or Unit 3 in Calculus 3, was on extending integration in a way that we talked about multiple integration. So we did 3D Riemann sums. We talked about double integrals, their definitions and approximations, iterated integrals, applying the fundamental theorem of calculus to those. And of course that was double integrals, but then we also did a triple integral and iterated triple integrals. We talked about changing variables in integration, polar coordinates, cylindrical coordinates, spherical coordinates, and then using Jacobians to do other types of changing of variables. And some of the applications we looked at along the way were area, volume, average value, mass, center of mass, moment of inertia, and probability. So this is kind of where we are at this point, is we've done these things. So what's coming up? Well, what's coming up is going to be vector calculus. This is going to be our 16th unit here. And on vector calculus, and it will be over derivatives and integrals of vector functions of a scalar. We may actually review a little bit of parametric graphs first, parametric curves, and then we'll get into derivatives and integrals of a vector function of a scalar. arc length and curvature, vector functions describing motion along space curves, so particularly talk about position, velocity, speed, acceleration. Then vector fields, we'll talk about that a little bit. We'll talk about what's meant by conservative vector fields and a potential function. Then we're going to talk about integrals in a different kind of integral. We're going to talk about actually a couple of different kinds of integrals, line integrals and flux integrals or surface integrals. And so we'll talk about those two things. We'll talk about a couple of important concepts related to these called divergence and curl. And we will also talk about sort of 4 different versions of an analog of the fundamental theorem of calculus, sort of vector versions. One will be what's called the fundamental theorem for line integrals. Then we'll talk about Green's theorem, Stokes' theorem, and the divergence theorem. And these aren't all necessarily in the order that we're going to be covering these topics, but these are the basic topics for this unit. So come back in our next video. We're going to start with some parametric curve review, and then we'll jump into some vector stuff after that.